we were playing Valorant. That was no fun. We take very seriously the role of the game designer. That helps the game developers in general, the team that makes the game, helps them to perform and deliver a game experience. But it goes back to the game designer to worry about the experience the player gets. Take this very seriously. Perhaps you think it's too serious. That's fine. That's fair, actually. This channel is about talking about the role of game design and best practices of game design insofar as it relates to game development. And so when we play games, we are also analyzing them. We're going to talk about our game that we're making called Shuffle Wars. And we're going to talk about what we learned when we played #Blood last. #Blood, we're going to play this later. It's a beat 'em up. It looks cartoony. It's very cool. I might not be the best at video games, despite the fact that I am a game designer, but the boss that we ran into, I was fighting, and I knew it was going to be tough. Actually, there was one attack I could do in #Blood. You're fighting vampires, and instead of wooden stakes, you can use pencils because you are in high school. You got pencils, you throw pencils, it's your ranged attack weapon. That attack totally worked on this mini boss. And I say it totally worked. It like took three hits, done, dead. That's what it seemed like. And along with me learning that I only need to fire a few of those pencils, that the pencils could kill the enemy, and therefore I should wait till it actually hits before I decide whether or not to fire the next pencil. That aside, right? I'm going to learn more about pencils, yeah? Okay, fine. Me as the player has some room to grow and learn, yes. The melee attacks, which I had been using the entire game, weren't doing anything to this boss. But I didn't know that. Let's go to the most explicit. It wasn't a wall of text printed to me on screen saying, the boss will not take damage from melee attacks. Pardon me, apparently I am under the weather right now. There was no wall of text that was making it extremely explicit. Let's go one level down. Was there a more subtle thing, like a health bar that wasn't going down for the enemy? No, there wasn't. Were there other indicators that the enemy was taking damage that was telling me that this enemy was taking no damage? Not really. So to be fair to #Blood, what was there were animation frames, and having some background in animation, I can respect that. There were particular frames in the attack hit cycle of the enemy when I hit them that would show a portion of their body flashing red. The part of the body was in a blocking pose. However, in the scheme of the silhouette, if we're talking about animation, let's go there. The silhouette did not show me block. No. But the frame, if I saw the frame, I could see the pose and notice potentially the very quick flash. And that was the entire communication to the player saying, this enemy takes no damage. Well, my complaint of that was, hey, How do I know what that means? I'm the player, and I don't know what that means. Like, help me out. In other words, I was attacking the boss thinking I was doing damage, and there was nothing that I could see that was saying otherwise. Every enemy has always taken damage from my big attacks. In fact, I just got a big upgrade on these melee attacks, so I was like, right on, I'm going to use it here. So my complaint, once I did figure it out, and by the way, I had to spend all my health packs to do it, which made it frustrating. My complaint was, my complaint was this wasn't communicated to the player. If there was any of several different kinds of communications to players about damage they do to enemies, where you saw that it wasn't doing damage, that would have done it. And I would have been like, oh, this melee attack is doing nothing. Instead of continuing to try the melee attack, getting hit and hit and hit and having to use all my health packs before I ran out of all of them and had no choice but to try and go after this boss with nothing but melee attacks that did nothing. It was only then that I began to see the pattern of the boss where they were vulnerable. To be fair to Blood, that was a pattern of boss attacks where they are vulnerable at a point. However, not enough communication. Particularly, not enough communication on the fact that my attacks that had been doing damage to every enemy now were not doing damage to this enemy. That was not communicated well. And I said, if they had just chosen like a health bar or floating numbers to indicate when damage was done, to tell me that damage wasn't being done, I would have gotten the message. Instead, out of desperation and being stuck with no options, I eventually was forced into a place where I found the boss pattern. But had I been told that information, I would have found that pattern a different way and saved all my stuff. So as a player, I'm sad I lost my health packs. As a designer, I'm sad that they didn't communicate to the player the appropriate thing. Yes, I'm a nerd. Get used to it. So in line with talking about game design and best practices, I said, oof, yeah, that was a missed opportunity to help the player learn the game, play the game better. The rules here include, hey, this boss does not take damage from melee attacks. And I said, there needs to be communication to the player that says how much damage is being taken. Hey, we don't do that in Shuffle Wars. Maybe we could. You see? So here we are making this game Shuffle Wars, and if I just jump into a quick play, while I do two other things, I'm going to mirror the formation of this opponent. And I'm going to show you what I have now are indicators of how much damage is being done for every attack. The idea was, hey, hashtag Blood really should have had this because communicating to the player how much damage is being done helps them understand the rules of the game. In our case, this is also true. I can say, well, actually, let's back up for a second. I can say, for example, here's the tutorial about how to play Shuffle Wars, and here is what the stats mean: power, defense, speed, health, and luck, and here's what they do, right? Words, wall of text. This is actually very inefficient to communicating to players what's going on. Power minus the defender's defense. What? Math? What? That's the damage being done to the defender. What? I don't understand. The more power I have, okay, more damage I do, sure, but it matters how much defense the defender has. Right? Well, what does that mean? See, that's a very inefficient way to communicate to a player what is going on. The more efficient ways include multi-channel communication. So if I can show it to you in words, that's one way. If I can show it to you in sound, that's another. If I can show it to you in visuals and animation, that's another. So I said hashtag blood could use visual indicators about how much damage is being done. And I thought, why don't I throw in numbers that are showing you how much damage is being done when an attack is done? And so what you're seeing now are these numbers floating out showing how much damage is being done. And you can see this card is taking 4 hit points of damage. In fact, we haven't communicated exactly this in real time to a player at all until just now. And I'm now realizing not only was that a good idea from hashtag blood to here, but turns out, yeah, actually this is a big miss on my part to notice that this was necessary for the player. To communicate how powerful these cards are and how the choice of cards you make matters, this is necessary. My goodness, my voice is really thrashed and I didn't realize it. So what are we saying? I have this idea. I began to throw it together, and the idea is there is an angle from one card to another in the attack. Let's just continue that angle and have numbers reflecting how much damage was done float away from the defending card in that direction. Just continue that direction. So it's like it got hit and the number is being knocked out of that card. This is cool. This kind of looks like it, yeah? So let's go into development mode, because technically we skipped development yesterday. My goodness, my voice is really struggling today. I didn't realize that. All right, so I made a script. Specifically for this feature, it's an overlay of damage. It's going to go with our prototype script that's running the battle, but I didn't want to add it to this battle script. I'm just going to add, it's a completely separate feature. It's easy to make it separate. To be fair, I do attach it to the same tool that is running the battle script. So this tool is here. I just attached it. And I'll talk about these 2 public variables here that I use. One is the red that you see when the number appears. It fades in and fades out. And the other is the animation timing. And we'll talk about the curve doing the timing. We'll talk about that in a minute. So I made this script, and not to put too fine a point on it, but the key is I want the prototype battle script to talk to this script and say, somebody did damage to somebody else. So add a strike, what I'm calling the overlay of damage. A strike, add one. Here's the amount of damage. Here's the position of the card that attacked. Here's the position of the card that was hit. Done. Because this is easy for the prototype battle script to No. So I can just call this because all this information is known. And importantly, this is the information that the player needs to know, right? It's helpful that it comes from one place and goes to another, yes. It's helpful to indicate that with motion, true. But this number is the critical piece of information we have not used until now. So being able to call this function from the prototype script is the key. This script can handle any number of strikes at once because I don't know how long I want them to hang out. I don't know how fast I want strikes to be able to play. Could be that a pearl attacks a bunch of cards, and in fact, I need to add this to pearl attacks. And that way there'd be several cards that, several strikes that need to be displayed at once. So this script handles any number of them and adds to a list of strikes that is currently managing. It populates the amount of damage, where to start, where to end. And just to put a detail on it, I'm converting where this is in world space for the game into screen space for the overlay. So it can display it as an overlay. I will show you why, but the short explanation is we do camera shake, and I want the numbers to not shake. So they don't exist in the real world, they exist on screen. So they stay still while the camera shakes. Okay. I need to do a little bit of math just to have it positioned in the right place, but then I say start here, go from there in the same direction. This is, I could talk about how a vector is also a position and a direction at the same time. But that's what this is, a direction. And then that direction is going to go for a particular length that I can tune. It will start at the start. It will start with the starting color, and there is a little bit of a delay to match the timing of the animation that the visual effects are already there for attacks. There are visual effects there already, and there's a little delay that I need to add. So I add strikes. This is then run every frame. The running is typically just I'm able now to do something every frame, which in this case is handle a delay, and then manage progress and the animation through that curve, which I will talk about, so that the number can move from one point to another. That's what this is, and can also change color over time, which is what this is. And if it has gone too far or it has gone to the end, I want to know about it so I can remove it. That's what this is. So running strikes happens every frame. If I do remove it, that's just a matter of saying take it out of the array of strikes that I'm currently managing, and done. This can handle as many strikes as I need at once. That's about it. I then display this on screen, and because these strikes already know screen space, it's actually pretty easy to do. I just say, give me a label with a negative sign and then the amount of damage. That's it. Cool. Since this is a game development sort of stream that I'm making up for, I will tell you that I had this idea, again, coming from #blood, to have some sort of indication of the amount of damage on screen and show that to the player. And I broke that down into functionality to say, oh yeah, I might want multiple strikes, and so I should have an array of those. And I should manage them as I normally do with the patterns of managing arrays, and I should make a tool the way I normally do. So I stopped thinking about the vision of this feature and just coded. Just sort of turned my brain off and did patterns of code that I normally do to manage arrays, to set up a tool, even to display stuff on screen. These are all patterns I normally do. I did that and sort of set it down, woke up in the morning, and went back to it and said, okay, now let's integrate it back with the vision that I originally had. That's where I found problems with it, integrated it, tuned some of these variables a little bit, realized the number needed to be bigger, it needed to stay on for longer, etc. And so now it looks the way it looks, which is okay. It's pretty cool. Let's continue with that, because this is, frankly, the fun part. This is the part where it's more interesting to see what you can do with the feature now that it's sort of in place, right? So let's go back and look at this again, because now that we know the behind the scenes, how this was made or whatever, right? And we see the vision of what we are trying to do in general, let's be specific about it and fine tune this, because we now have control over the color, the animation, and all the good stuff. Let's do that. So again, I'm going to mirror the formation of my opponent cards so I can clearly see these attacks one after another, and we can just talk about them. So it's a display of this feature. So we'll see the attack and some minus some number floating away from it, right, in that angle. So all of that is already figured out, which is great. How could it be better? This is a step in design that just sort of highlights the idea that design really doesn't stop. Design doesn't say, okay, done, right? Development might say that, but design does not. And what I mean is there is a point at which functionality, like in this case, is relatively complete. And yet design asks, well, how could it be better? How could this display be better? I, as an animator, would point out that the animation of the numbers floating away is linear, really sort of gentle and obvious. In emotional terms, it is comfortable but boring. And that's in stark contrast to the other visual effects we got going on, which is rather dramatic and snappy, quick. Now that I'm pointing out this detail, you might notice, oh yeah, actually, it doesn't quite match the power of the camera shake or the visual effects that are already there. What can we do about that? Well, there's a couple of things. One, and this, to be fair, I had this in mind because, again, I do animation as well. One is the color can also be animated. We are gently fading up and gently fading out, but it's basically red the whole time. The other way we can affect the look of it, the feel of it, the emotional quality of it, is by affecting the motion. So here in the proto game scene, the game scene that we see when we're playing the core game, this tool now has those two variables that we can play with to do this. First of all, the gradient. In our code, there were two functions that look at these two variables, and each of those functions was called evaluate. What it means is, like in the case of this gradient, evaluate what the color would be based on a progress between 0 at this left side and 1 on this right side. 0 and 1. 0% and 100%, right? Evaluate was the name of the function, and it results in a color. In this case, is it faded out or is it full red or whatever, right? Well, same thing for animation, because this curve can also signify 0% on the left side and 100% on the right. By default, it does this, linear interpolation. That's what I meant by linear. It's a straight line. At the left side, it is 0% through the progress of motion. And at 100% of the time, it is 100% of the progress through motion. So in other words, it just kind of goes based on time. That's what this linear graph shows. What we want is something that shows the power of the hit. The power of the hit is quick, and it might need to settle at the end to show the number clearly to the player. Eventually, this is all going to the player. And part of what we've already got communicating is the clear number. It's big, it's bright, that's cool. But this linear motion can help us communicate more because we can, for example, settle into the end to make the number easy to read at the end of the very short time that that number is there. And at the beginning, we can, we can show a lot of fast motion to show the power of the hit. So this graph is now showing that at 0 time, it is in the 0 position, but almost immediately it starts to move very rapidly. This is a lot of progress in the motion based on a very short amount of time. So the steeper we make this curve here, the more snappy that motion becomes. In this way, we have a lot of motion right away, and then it settles for almost half of the timeline. This will make it very easy to read. It'll be very quick to start with. This would basically, if I'm moving my cursor in this way, this would be like snap, where it settles at the end. Snap, where it's kind of like if I'm doing it in slow motion, it's like boom. Done. So that it's easier to read at the end, but shows the power of the hit in the beginning, and that should come closer to matching the power of the visual effects that are already there. See where I'm going with this? So now I'm going to just sort of tweak this because I'm a nerd. This is close. Good. Done. This curve will now be used. I mean, it was already being used. It's just by default was going to set it to a linear interpolation. This curve is now going to be used for our motion of the numbers that are displayed when a card does damage to another card. Cool. Let's look at the gradient now, because like I said, these are two things that we can use to help show the power and the emotion of this hit. Yeah. This so this variable type, the animation curve, is super useful. I do use it often because I'm a nerd and I like animation. This is another variable type I like to use. It's called a gradient. Instead of just color, which is one of these keys right here, I can use color over time. And so while it's red and red at 0% and 100% and all in between, it is just the same red. There's another channel that we can play with, and that's on the top. This is alpha. On the top here, these keys are indicating how much alpha there is. So 0%, 100%, and I can add more, and I can drag them off to delete them, and I can set this, yeah? So check it out. I do like that it fades in and fades out. Cool. Based on the total time that I have for this effect, this will work great. The color now is something I want to play with. And in fact, I might play with alpha later, but because I'm a nerd, but I'm going to go ahead and use the color hue and saturation and value alone at this point. So I'll just jump into like 1/5 of the way through the timeline and make some keys here. I think what I want is sort of a flashy, stuttery kind of a thing that starts very rapidly and then begins to get slower and slower until it is just red and fades out. So let's see, red, let's say not red, red, not red, red, not red, red. Okay, that'll work. In that way, I have, just going to use some Fibonacci numbers because okay. In this way, I want to have more going on than just the motion being dramatic and impactful. I want the color to help with that. And it could be that I need even more going on in the beginning of this. This might be a little too calm for the kind of impact that I want. But let's see. The alternate color, I'm not sure. I'm not sure yet. I like the idea that it's full saturation. That's okay. But I might start out at something more along the lines of this, like a yellow, not so green, maybe like this, 50, sure. And then gently get back towards red. Okay, that's fine. That's cool, because that looks a lot like the colors that I used for the visual effects now. It also sort of, mirrors what colors are going on with fire and explosions. So yeah, it's impactful. I'm down. So if that's true, then this first, let's see, red, not red. Okay, so I'm going to do another key here. In other words, it's going to stay red all the way, and now it's going to be not red. And I would like to be up here, I think. Yeah, it's good. So then red, and then not red. And we're going to go much less than that, I guess. Cool. And then red, and then not red. Whoops. So whoa. I'm trying to add another key. Can I add another key, please? Why is this doing this? Hello, Unity interface. What are you wanting to do? I'm wanting to do something different. Can you help me out? Huh. Maybe. Like I'm picking a completely different key to try and kick this into place. That's odd, right? Is there a limit to the number of keys I can have? I reject that reality and insert my own. Why would there be a limit to the number of keys I could have? Well, that's sad and wrong. I don't want that. Well, all right. Let's pretend there is a limit to the number of keys I can have. And if that is true, I will work with these keys that I do have. Sad. All right, so it's just a couple of flashes. That's less than what I want. But there are flashes, and they might be a little late, actually. This might be a little too gentle. But let's see. It might be that it's moving so fast, I need it to stay static and relatively calm in terms of color. And then as it slows down in terms of motion, it can flash. Maybe that works. Maybe that doesn't. This is a good guess. We will try it out. Oh, it does tell me there's a max number of 8 keys in a gradient. Gosh, really? That's sad. I never even ran into that limitation before. Excuse me. I really didn't realize how rough my throat was this morning. Wow. Okay. Well, I'm almost done, so. What we have now is some animation showing the amount of damage on a hit. It does move out quickly and then eases in to show you the amount of damage. I'm not exactly seeing that flash, though. Let's try this again. Sorry, I may need to end stream soon. I'm just going to try and get through this. Excuse me. So, yeah, I'm not quite seeing the gradation flashes. I am seeing it vaguely change color from like orange to red, but only at the very end. It is going by pretty quick. So in that way, I bet it's going to be helpful to do keys on the gradient that are in alpha as well. And we can try that. I may also say it's useless to try and do the flashes early because it's moving so fast. Like the motion is fast and we can't quite track the color changes. So that's useless. So I might just move those down a little bit in the timeline on the gradient. Motion's pretty cool though. Yeah, so let's adjust this a little more. At this point, we're just adjusting the settings on this tool. You see, we've made the tool, now we're just adjusting the settings. So what I'm saying is, maybe these can be moved down here. Right? Maybe it needs to be the same color for a while. While it's moving quickly, while it's moving quickly, keep the color consistent and then flash it. That sounds reasonable. Let's try that. So this gradient is a timeline as well. Right? All right, I'll try this. Not sure about it, but I'll try it. And I mentioned I probably want to flash as the alpha as well, so I will try that. It's going to be 0 alpha, full alpha, 0 alpha. So that it kind of goes kapow. Right? And again, it might be useless to try and do that while it is, might be useless to try and do that while it's moving so fast. So I'm going to take a good guess that it's probably got to be like this. And evaluating animation can be really tricky. Gotta be honest. You get used to seeing things quicker. Sort of ruins movies for you from then on, because you end up seeing things that people don't normally see. But let's try this. It should flash a couple of times and then flash color. And this might be visible. I also kind of want this to be snappier somehow. That'd be great. So I'm actually going to make a new key, make it flat, put it up at the top, in other words, 100%. And you know what? I'm going to do Fibonacci numbers. And that means that I can make this. Steeper. This is snappier. Now, if I go too far, right, then it goes more than the progress, which won't look right in terms of the animation that I need. Also won't evaluate well. This will be snappy. There is some sense in perhaps maybe kind of sort of keeping this running. In other words, not exactly 100%. And here's where nerdy me is going to just noodle this to death. So I'll just go there and call it good. Okay, so it is going to get almost all the way there and then kind of chill. While it's still moving, it's moving very slowly. So it's snappier and flashes in alpha as well. So this is what I mean. We're now going into the details. The designer does not feel satisfied with anything. The designer is going to continue to believe there are improvements to make. Designer's never done. And in this case, it's the animator's never done. I'm looking at this detail and talking about how I'm communicating to the player, talking to the player. And I'm saying the card has done damage to another card in this amount. And I'm looking at how well that's being communicated. Well, it's certainly snappy. That's good. Might be going a little too far out, actually. I like the flashes too. I can see the color flash for sure because it's slowing down. I'm not sure that I see any of the alpha flash, and I'll bet it's because, first of all, it's on top of the card. So it's hard to see. It's also moving quickly, so I'm not seeing the alpha flash that we just added. I am seeing the color flash, and so I can kind of read the number a little bit better. And it's easy to see that it's the damage that did this. Okay, that's better communication. And it's because of the changes we made to the motion for sure. Now, some of the color changes are okay, but this flash in alpha is doing nothing. I'm not seeing any of that. And I'm trained to look at very quick things. So this is not useful. Like, I don't see the use of flashing it in alpha because it's really not readable at all. So these are kind of useless. Interesting, though. I wouldn't have guessed that. I guessed the other. So fading it in turned out to be a good thing to do, but I'm going to fade it in like this, I think. Yeah, that's reasonable. And then flashing it a lot while it fades out. I think this is okay. This is okay. The motion is good. So there's one other, say again, it already works. Are we done? The designer's going to say no. There's always a place where it can be improved. And here is another way this can be improved. We're trying to communicate to the player how much damage is being done. And we're showing it with the motion of the attack at the right time, on the right card, in the right angle. It's a number, it's flashing, it's pulsing, it's red. There's lots of ways that we're communicating. All these channels are all saying this is damage being done, right? To say that we're taking that health away from that card is another way of saying we're doing damage. So one other way to make this, like, in short, look better would be to have this start as a smaller number and get bigger and bigger as it goes away and fades out. In other words, grow in size as it's being pushed out of the card. Right? That would be another way to make this look better, to communicate to the player this is damage being done to that card, because you can see it coming out of there, and it's not a number that's just going to stay there floating. It is actually disappearing. It is damage being done. It is health being taken away, and it is gone, being pushed out of that card because of the attack. So if the number didn't just move out and flash a bit and fade out, it also got bigger. I think we have time to have it small in the beginning, smaller, and we definitely have room to grow and make it bigger as it comes out. Maybe this ending size is okay, actually. So we're talking about the font size. Smaller font size in the beginning, probably leading to a font size that's bigger than what we see here. I'll bet that's going to do it. So I'm going to add an extra part to this feature to make the font of this number grow as it leaves the card. Right? Damage is being taken away. Right? I think that'll help communicate a little bit better. Yeah. I mean, it's much easier to see that this is damage being done, that different cards do a different amount of damage. Boy, when there's 5 cards on screen, the distance is actually pretty far. Could probably lose some of that distance. Keep that in mind. Watch it again with 3 cards. You see there's a big difference. It's because we're closer to the cards. The cards are bigger on screen. That distance is the same in screen space, but it's... So the numbers actually look small compared to the cards. The distance looks small compared to the cards because we're closer. Because there's 3 cards, not 5. Wonder if I should adjust this for size and stuff. Well, whether you can read these numbers clearly or not, the idea that there is health being knocked out of, I mean, it's also red, but the fact that there's health being knocked out of these cards is clear. Now that communication is happening, so I'm happy about that. And yet, this can be better. So let's go back. I can do this all in code. I don't need to adjust the properties anymore. This is the script here. We currently have a set font size. And I'm going to say there's a minimum font size. By the way, at 1024, I'm talking about the width of pixels on screen at the moment. Okay, I'm going to save that. Probably going to increase this. That might be too much. We'll do this. I don't want it to be too subtle. And that's typically the problem I have. So this is also a animating feature, right? The size of the font. And it does need to be a integer. That's okay. I see this has a strike time. There is a max strike time, so I can use those. Okay, a little bit of math here. I might just condense this back down to a single line of code, but for now, I do want to say I want to round to an integer for sure. But I'm going to use, this is the calculation I do. This is why I had 1024. It's the calculation I use based on the actual screen width as it currently is, so it always scales appropriately, despite what I want. So this size, font size at that width works great. If it's bigger or smaller, this adjusts appropriately. I'm going to add something to that, which is it has to do with the max strike time and the current strike time. Because this is now a proportion, and I'm building this algorithm as I go. So that's a percentage from 0 to 1. As long as this is not negative, actually. Long story short, I do some extra magic with this. Strike time is more than 0. Thank you. Okay. Yeah. This is the normal calculation we do. Now I can use this because this percentage, right? Now if I multiply 0 times anything, it is 0. So in order to get it to a minimum, the minimum font size, well, I'm clamping it really. And let's see. Between the minimum, let's start with that actually. I need to give myself some space and think this through, and then I'll condense it again. Big deal. There's the minimum. And then there's the font size. I mean, really, that's a lerp, is it not? It is. It is. Linear interpolation. Let's call it L for now. I'm going to redo all this, so it's okay. Lerp. Lerp means take a minimum and a maximum and then some amount between them. I actually do this to do the gradient, to do the animation, all that stuff. So, yeah, I know the minimum. I know the maximum. And I know the amount, which is this percentage. So here we go. That's what I needed. Now I have a linear interpolation which is between these two integers, and it is a float, but that's okay because I can use that float now. Boopity boop. I'm actually doing this. Except not that, but this. So find the number between these minimum and maximum, and then use that based on the screen size to round it and make it a thing. Done. Okay. Yeah. Oh, and by the way, yes, be at that size unless it's not. Yes, okay. Actually, if this is... Yeah, let's be efficient here. If this is got the wrong strike time, which I'm also using for a delay, that's what I'm talking about. If this strike time is less than 0, right, I need to skip this altogether. In loop terms, that means continue. So if it's equal to or greater than, then it's going to do something. Otherwise, it's in a delay. I used the negative numbers on the strike time for a delay. So now I don't need to do this. No. Stop. This is where I'm going to make this condensed. Boom, boom, boom. Okay. So I am finding a number between these two, and then I'm using that there. Okay, this should be a very smooth transition between these two. It's on an integer, but font size going up from, 28 to 29, it is animation. It is going to be fine, especially if it plays quickly. So it should work. Based on the time and the max time, use that percentage to go between a minimum and maximum, and then make the font size go with that. It should work. Should be good. Famous last words. Let's try it out. What we're looking for is the number not just moving away in a snappy way, not just flashing a bit in color, but also growing in size before it fades out. It is. And by the way, this is also a linear interpolation. I wonder if we should use our animation curve to help make it more snappy, because it's already set to be that, and we can evaluate that as well to do the font size. So I'm just looking at the animation of these numbers flying off of these cards as they get damaged, and kind of trying to evaluate how easy it is to read the motion as well as read the numbers. But I mean, you can see the pulse, you can see the flash, you can see it growing, but it is very gentle. I'm not really sure that helps. And it is flying away pretty far, actually. So let's adjust. Let's adjust some things. The length that I have here is a tunable variable I'm using. It means a percentage of screen space. That's how I'm processing this. So this is 20% of the width of the screen, which is pretty far. I can just tune that down a little bit. The time is 1 second. Delay is a little bit less than half. And the size. This is the amount of. Am I using this actually? What is this? Oh, right. This is the actual size of the space in which I draw the font, and I need it to be big enough to display the font. That's all. Okay. Then this is the actual font. And yeah, actually, this could be bigger. I say it like a question, but I know it's not a question. It is a statement. Okay. I'm going to overshoot it and then tune it back down when I say that's too much. And I do want to evaluate this. I want it to grow, not in a linear way, but in a way that is more like the animation curve. And I have that. Check it out. This strike curve is the name of my animation curve. And I can ask it, please evaluate and give me a single number based on a percentage. Guess what? That's exactly what I have, a percentage. So that's all I needed to do to get that to now be not linear, but in fact snappy like the motion. It's exactly the same curve. So let's try it again. And I hope anyone looking at this sees the tenacity, doggedness with which I'm going after the smallest details. I hope that you notice the tiny differences that I'm caring about at this point. Whereas before it was a major feature, and then it was a gross or large property of that feature. Yeah, this is very snappy, getting to that very large size quickly. So quickly, in fact, that it's actually hard to see anything small about it. Let's try it again. And I do notice that it is a shorter distance. That's good. I actually think that's pretty good. We lowered this distance that the number travels from the card after it gets hit. I also increased the ending size. Yeah, you're not going to mistake this. You now see damage getting taken away from cards. Absolutely. Yeah, you don't miss that. Oh, this is a detail I thought of after I coded most of this. If there is a luck win, I'm not accounting for the fact that I should show damage. I guess, should I show damage going back? So luck win means this is now left with 1 hit point, where it was going to die. So it didn't really lose 1. It was going to lose 1. That's a detail rule change I might need to implement. If there is a luck win, what do I show in terms of a damage overlay? Should it show 0? Should it show nothing? And should it just show the damage from the attacker because the attacker lost all its health? Maybe that is what I need. Wow, you really notice how many times it just does 1 damage. That's why these battles last so long. If the defender has a lot of defense, yeah, that's what's going to happen. There you go. There's some 5s and 6s. Yeah. Boy, you can really see damage being knocked out of the cards. This is very clear now. It adds to the battle in terms of information. It adds to your understanding of the cards that you picked. Over time, players will learn which cards to pick to get higher damage, and then they'll see that number pop out and they'll feel satisfied that, yes, they predicted that to be true. This is good communication. I'm going deep into the psychology of it, but this is good. Back to the tuning so we can finish this. Yes, I may need to add a part to this that does something for a luck win. That condition is specific, unique, and I do need to do something about that because the card that turned it around does not take any damage, or rather it is left with 1. So they may actually take damage, but the attacker takes a ton of damage. I'll have to deal with that. But right now I'm just dealing with the tuning of this because I think it's pretty much there. I'm almost happy enough to let it go because that's how designers talk about being done with a feature, is they're letting it go. There's nothing worse than being done with a feature and then seeing problems with it. So that's how we have this anxiety about these features. It's a good kind of anxiety. It's helpful. Okay, this is pretty clear. I'm almost happy with this. I'm not exactly happy with the change we just did to have it grow fast and snappy, because I got to be honest, it's too snappy. I don't see the small, I only see the large. Because by the time I'm looking at the numbers and reading it, it's already big. So it would be, I guess, obvious to just make a new animation curve and use that instead. However, I'm going to be tricky and try to use a proportion of the existing animation curve instead. Let's see how tricky I can be. I mean, I can kind of see it growing, but just not very much. I mean, I kind of want it to continue to grow as it fades out, and I really see the growth as it's flashing, which isn't terrible. It's just not exactly what I'm looking for. So again, we are talking about the tiniest, most subtle details there are. And at this point, I think this is going to be the last adjustment. So if I did overshoot this at all, and I think maybe I didn't exactly overshoot it. Let's say it this way, though. If I have this smaller in the beginning, it'll be easier to see it. And maybe the size at the end wasn't so bad. Now, if that's true, then this is the last part I'm going to do, which is this curve is cool. It's just super snappy. And this is going to result in a 0 to 1. That's true. How do I get tricky with this? So a linear interpolation would be this. This is what we had before. Because this is just a percentage based on time. Time just marches up to the maximum done. This is constant, it's linear. processing that with the animation curve got us something else. I don't really want to make a new animation curve. It would certainly be simpler than what I'm about to do. But if I take this instead, I mean, I could average this and a linear interpolation. I guess I could do that. Gosh, this is kind of silly, but why not? Let's call it silly because it is. Because it is. First, start with the linear interpolation. This. Done. And now that I have that, let's add and then divide by 2. In other words, average. So this is going to go between 0 and 2, right? Because each of these goes from 0 to 1. But they go at different times. I don't care at this point. I'm just looking for in between the two. If I'm looking at the actual curve line, it would be like, here's the linear and here's the snappy one. And anywhere along that line, it would take the average of them, which is gentler. It's just gentle. It's silly. It's silly. It's silly. I know. Add them together, divide by 2. Done. I know. I say it's silly because I am dealing with a tiny, subtle detail. I say it's silly because I really could have just added a new curve and had more control over it, blah, blah, blah. But I like the other curve. I just want exactly half of that. I want to try that. I'm pretty sure that's going to look great. Let's test that theory. What we're looking for is the growth of the number as it leaves the card that is taking damage. And that growth being visible, more visible than it was before. Not quite. It's not quite more visible. Let's look at it again. The growth of these numbers as it flies off the card. I'm actually not seeing it grow at all. Yeah, my silly math is not working. Yeah, let's try it again. This takes the linear and if we do nothing with that and try it again, oh, yeah. So interpolating between minimum and maximum, yeah. That is exactly what we had before. So this should look like the amount of growth that was really not snappy could be better, right? That's why we went down the road of looking at using the animation curve at all. So this should look too tame and gentle. Yeah. Definitely growing. Really obviously growing. And before it was definitely not. So it just wasn't working before. So I kind of want it to be, yeah, exactly halfway between the animation curve and the linear, because you can read it growing when it's linear, but it's not snappy. So this works and could be better. The other one is kind of better, but I'm almost liking how this looks though, actually. If we do this, this will now look. So I'm testing in different ways and comparing them visually and remembering the previous one. This is called an A-B test. A-B test. Compare one way to another. And let's see. This should look like it grew so fast we can't quite tell that it is growing. Yeah, I can barely see it growing at the end. And so what I wanted was somewhere in between the two. Okay. So I do want to add the two and divide by half. Dum. My math was wrong. So I could multiply by 0.5. That's the same. Yes. Dum. Math. Try it again. I was just a silly math bug. Check. Yes. Okay, good. So now we should see this look better. This should be the subtle difference between the two. Splitting the difference between animating too fast to really see it grow and growing too slow to show enough emphasis and power and emotion in the hit. Yeah. Okay. Ready? I can see it grow. Yep. It is